Hello everyone. We are going to start the new Syllabus Mathematics edition 8, exercise 1C part 2. Question number 13. Shah needs to pack 171 pens and 63 pencil equally into identical gift bags. So she has 171 pens and 63 pencil. It is needed to divide into identical bags equally. It means that obviously a number of pens are more, so the number of pens will be more as compared to number of pencils. So the largest number of gift bags. So largest number of gift bags, it means we need to find the SCF. SCF of 171 and 63. So to get largest number of bags, find the SCF of 171 and 63. So factorization of 171, that is equal to 3 raised to power 2 into 19, and factorization of 63, that is equal to 3 raised to power 2 into 7. So SCF, that is equal to 3 raised to power 2, that is equal to 9. So if you want to find factorize 171, that is 3 5 3 7s are 3 1s are 3 3 9s are 27. So this is 19, 1 time 19. So this is 3 raised to power 2 into 19. And for 63, that is equal to 3 2s are 6, 3 1s are 3, 3 7s are 21, 7 1s are 7. So 3 raised to power 2 into 7. This is SCF. So we can write that largest number of gift bags, largest number of gift bags equal to 9. Number of each item in bag. Number of each item in bag, that is equal to pens equal to pens, that is 171 divided by 9, that is equal to 19. And pencils, that is 63 divided by 9 equal to 7. So answer is 19 pens and 7 pencils. This is answer. Question 14 is sweets are sold in packs of 120 while mini chocolate bars are sold in packs of 18. Sarah bought same number of sweets as many chocolate bars. Find the least number of packs. Least number. So we need to find the LCM. So we need to find the LCM of 120 and 18. Factorize 120. 2 6 are 12, 0. 2 3s are 6, 0. 2 15s are 30. 3 5s are 15. 5 1s are 5. And 18. 2 9s are 18. 3 3s are 9. 3 1s are 3. So 120, that is equal to 2 raised to power 3 into 3 into 5 and 18 equal to 2, 3 raised to power 2, and LCM equal to, here 2 raised to power 3. In LCM we will take the highest power, that is 3, and 3 raised to power 2, and then 5, 8, 9 into 5, multiply all together, we get the 360. So she bought 360 sweets and 360 mini bars. And next it is asked that packs of sweets, find the number of packs of sweets that she could have bought. So number of packs of sweets equal to 360 divided by 120. So 12 threes are 3 packs. This is answer. So question number 15 is, two race cars, car X and car Y, are the starting point of a 2-kilometer track. At the same time, car X and car Y make one lap every 60 seconds and every 80 seconds respectively. So there are two cars, car X and car Y. Car X is faster, and car Y, I mean that car X is faster than car Y, because car X take 60 seconds for one lap, and the car Y covers same distance in 80 seconds for one lap. So how long in second will it take for both cars to be back at the starting point at the same time? So when they will be back together at the starting point? Car X takes 60 seconds per lap and car Y takes 80 seconds per lap. Time to return together at the starting point. So we will find the LCM of 60 and 80, 60 second and 80 second. So factorization, 60, 2 3s are 6, 2 15s are 3 5s are 5 1s are, and for 80, factorization of 80 is 240, 220, 210, 25, 51. So 62 raised to power 2 into 3 into 5, and for 80, 2 raised to power 4 into 5 into 5. So LCM is take higher power to 4 into 5, and also now 3, 16 into 5 into 3, this is 240. So 240 seconds. So part 2 is time for faster car to be 5 laps ahead. Time for faster car to be 5 laps ahead. So What is the speed difference? Car X is faster, so X now in 240 seconds car X covers 240 over 60 equal to 4 laps, and car Y covers 240 over 80, that is equal to 3 laps. So difference equal to 1 lap for every 240 seconds, and for 5 laps as required in the question, how long in minutes will it take for faster car to be 5 laps ahead? For 5 laps difference, 5 into 240, 5 into 240, that is equal to 1200 seconds. So in minutes, that is 1200 second over 60. So this 0 cancel, 6 to the 12 and 0, which is 20 minutes. So for 5 laps difference, the time required is 20 minutes. This is answer. Question number 16. Ken wishes to cut the biggest possible square from the rectangular sheet of paper without any leftover paper. So without any leftover paper, so it means that we need to take the maximum length. I mean, this is related to highest length. That means this is SCF. The sheet of the paper has length of 65 centimeter and breadth is 50 centimeter. So we need to find the HC of 65 centimeter, 65 and 50. Question number 16. Largest square side equal to HCF of 65 and 50, 65 and 50. So we need to find SCF. 65 5 5 are 25, 5 ones are 5. So 65 equal to 5 into 13 and 50, that is equal to 5 raised to power 2 into 2. So SCF will be equal to, in SCF we will take the smaller power, that is 5, only 5. So SCF is 5. So length of each square is 5 centimeter, and part 2 is how many squares can be cut all together. How many squares? So part 2 is number of squares equal to, that is 65 over 5 equal to 13, and 50 over 5 equal to 10. So total squares 13 into 10, that is equal to 130 number of squares altogether. This is answer. Question number 17. Find two numbers that each have exactly 16 factors, two of which are 8 and 12. So two factors 8 and 12 are given. So we need to find a number which have exactly 16 factors. So question number 17. 8 and 2 and 12 are factors. So what is LCM of 8 and 12? 8 equal to 2 raised to power 3 and 12 equal to 2 raised to power 2 into 3. So what is LCM? LCM of that is 2 raised to power 3 into 3, that is equal to 24. This is LCM of 8 and 12. So LCM is 2 raised to power 3 into 3. Now find the number with exactly 16 factors. For finding the number with 16 factors, we have a formula. If any number, suppose n equal to p raised to power a and q raised to power b, then we can find the number of factors. From this formula we can find the number of factor, that is a plus 1, this a plus 1, add this one, and b plus 1, this is b, and plus 1, that is equal to, what is the required number of factors? That is equal to 16. So now put the value of a and b for which this should be equal to 16. For example, value of a is 3 plus 1, this will be 4, and value of b 1 plus 1, that is equal to 16. 3 plus 1 4, 4 into 2. Actually for 16 we need to find the pairs. For example, 1 into 16 equal to 16, 2 into 8 equal to 16, and then 4 into 4 equal to 16. So these are possible pair: 1 16, 2 into 8, and 4 into 4 16. So first actually we need to make this one, this factor 3 plus 1, and next also 3 plus 1. So 4 into 4 16. This is one possible value. So it means that this is value A and this is value B. That means 2 raised to power 3 and 3 raised to power 3, 3 raised to power 3 equal to 8 into 27, that is 216. So first value is 216. And what about the next one? Now the other pair is this one, 2 into 8. 8 we can write 7 plus 1 into 1 plus 1. So if we see 8 into 2 16, so I mean that number of factors are 16 in this case also. So it means 2 raised to power, we have 2 raised to power 7 into 3 raised to power 1, that is equal to, so this is equal to 128 into 3, that is equal to 384. So 216 and 384 are two number with 16 factors. These are the two number which has 16 factors. And if we talk about first pair 1 into 16, so for 16 we can write 15 plus 1, and other one is 0 plus 1, so power 0. So power 0 mean that this factor 3 will be 0, so this is not possible. Power 0 mean that this is not required one. So if you want, this is actually final answer, but if you want to make sure, you can find the divisor of 216 and 384. For example, 216, let's find its divisors. 1 into 216 equal to 216, and 2 into 216, and 3 into 4 into equal to 216. So one is I mean that I wrote all the divisor of 216. So from here we can see 1 2 3 4 6 8 9 12 24 27 9 already written, 54 72 108 and 216 1 2 3 4 5 6 7 8 9 10 11 12 13 14, and so actually here are all the factors are written here. Actually they are total 16 factors here. 18 and 39 was not included here, so you can count from here 1 2 3 4 5 6 7 8, and 16 factors are here. So just I would like to explain from here, this is LCM of 8 and 12. Now for higher factors, I mean that other than this 24 LCM, any higher factor will be the multiple of this one. So this number is the base. I mean that if you see here, we wrote here 2 raised to power 3, 3 raised to power 3. Actually this is multiple of which number? 2 raised to power 3, and here 3 square is extra here. So this is actually multiple of this number. Similarly, if we see this one, 2 raised to power 7 into 3, this is also multiple of this LCM. What is extra? 2 raised to power 4 here is extra. So any higher numbers, if we write the higher numbers, then the number will be the multiple of this LCM. So base is this LCM number. So required is smallest h such that 528 h is a multiple of 540. For this factor, this factor to be multiple of 540, we need the missing factors from 540. So what is missing? If we compare, what are the missing factor here? So what are missing factor here? H will be equal to, compare this 3 here, 3 square is more, and other factor is 5, that is equal to 9 into 5, that is equal to 45. So 45 is the, when we multiply 528 with 45, then this number will be multiple of 540. So if we go on by writing the multiples, time will come, then this number, I mean, will be the divisible by 540, or you can say that this will be the multiple of 540. So if we find the HCF of these two numbers, HCF, that will be smaller power in case of HCF, 2 raised to power 2 into 3, that is equal to 4 into 3 equal to 12. So if we see the HCF, actually this is a divisor or factor of every number from which HCF is calculated. So it means that 528 over k is a factor. If it is a factor, that means we can write 528 over k, that is equal to HCF, which is 12, and 528 over 12 equal to k by cross multiplying. So now k will be equal to, divide it, 44. So this is a value of k. So for smallest n such that 630 n is a multiple of 1248, so we need to find the missing factors in 1248. So n will be equal to 2 raised to power 5, here 2 raised to power 1, so 2 raised to power 4 is missing, and 3 present, no problem, this is square, but this is not condition, 13 is not there. So if there is a more power, that is no issue, we will just consider when there is a less power, like in this case the power is 2 raised to power 5, this is more power, so we need to multiply with the remaining power, and for here 13 with 13, that is equal to 16 into 13. So this is the requirement, n should be equal to 208. So then it will be multiple of this number. So in part 2, find the smallest m such that 1248 over m is a factor of 630. HCF is a factor of every number from which it is calculated. So it means we need to find the HCF, that is equal to, here HCF equal to 2, 3, in HCF we write the smaller powers, so this is equal to 6, HCF is 6, so it means that 1248 over m should be equal to 6. Okay, now 1248 divided by 6 equal to m, and now divide this one, m will be equal to 6 2s are 12, 0, 6 8s are, that is 208. This is the answer. Next question is 20. A class is between 30 to 40 students. So there is no exact number, not exact number given here. So between 30 to 40, each boy in the class brings 15 chocolate bars for a class party. The chocolate bars are shared equally among the 20 girls. So girls are known, exactly 20 girls and one teacher. There are no leftover. How many students are there in the class and how many chocolate bars does their form teacher receive? So the exact number of people are not given here. Let the total students equal to x. So among them there are 20 girls. So it means number of boys will be x minus 20. And total bars equal to 15 into x minus 20, because actually number of boys x minus 20, and total bars, each boy brought 15 bars, so total bars number of boys into 15. Now these bars were shared among the 21 people, 20 girls and one their teacher. So total bar divided by 21. Now for total students, value of x is given between 30 and 40, but exact number is not given. You need to check by putting different value between 30 and 40, like 31, 32 and 33. It should be in the whole number. So I tried it for x equal to 34, that is equal to 15 into 34 minus 20 divided by 21. So 15 into 14 over 21. So 7 2s are 14, 7 3s are 21, 3 5s are 15. So 5 into 2, 10. So part 1 is how many students are there in the class. How many students? We tried 34. So number of students equal to students, that is equal to 34. For putting 34 value, we got a whole number, otherwise you will get the decimal. That is not the option, so we need only that full whole number. So number of students, this was question number 1. Next is how many chocolate bars does their form teacher receive? So part 2 is how many bars. So what are the total number of bars? Bars equal to total number of bars, that is equal to 15x, we receive 34 minus 20, that is equal to 15 into 14. So total bars 210, and it was shared equally among girls and form teacher. So total number, the form teacher received so total 210 among 21 people. So this is equal to 10. So teacher received 10 bars. This is answer.